Professor Wergely's here. We just got done with Media Play. I said there was a link online that talks about all the supported media formats. Here is a good document from Oracle. It talks about the media types. You'll see AIFF, AVI. These are all supported. You'll see the MPEGs are supported. QuickTime movies are supported. You'll see WAV files are supported. They also have other RTP formats that are supported. You'll see JPEG, MPEG, and that's about it. So it's kind of limited unless you use a third-party library that will help you read other formats. But if you use the common formats, MP3, MP4, MOV, then you should be fine. And a lot of the audio files can be converted into these corresponding formats. So you should be okay for the challenge, but you will want to be aware of those formats that are accepted. Now we're moving on. We're going to audio visual. So go ahead and download the zip. We're still on lecture number 26. Go ahead and load that into NetBeans. And now let's see how we can use an audio or video file, extract contents from that file, and display that on the screen. So let's look at the main class, AudioVisual.java. You'll see this is a Java FXML application. I'm loading the FXML file. That will create an instance of the controller. The controller is linked in the top of the FXML file. So if I go to edit, you'll see the FXML controller is here all the way over on the right. It's in the audio visual package and it's called player controller. So most of the work we're going to be doing is inside the player controller. Now you're going to see a lot of add.fxml annotations. So I have a lot on the display. If we open up the display, here is what we're working with. So I have a bunch of text. You'll see I have 1, 2, 3, 4, 5, 6, 7, 8 text. I have 4 buttons. So here's my buttons over here. Here's all the text. I have ellipses. So you see different ellipses starting with different colors. I have more text, and then I have image views as well. Okay, so I have a lot on this display. You'll see all of them have FX IDs, which is why there is so many add.fxml annotations, because that add.fxml annotation will take this FX ID and then essentially create the object for you and insert the object into this variable here. So I have all my variables. You'll see I have all my image views. And then I have a bunch of songs. That way we don't have to keep writing them out. You'll see the songs are over here on the left in the package. So I have a pretty good random mix of songs. Feel free to use these songs on your challenge. And we're going to start down here in the setup UI. Now, this is kind of a random mix of code. We're just going to see what we can get working, and we're going to see what type of information we have when playing this specific song. So I scroll down, you'll see I have a media player, just like we had before. I have handle play, handle pause, and I have handle next. We'll look at that here shortly, and you'll see I have is running. So I can determine whether the media player is running or not. It's a little bit different than the timeline, but similar concept. So if it's running, we're going to do certain actions. So just like we had before, we're going to go ahead and grab the media. So we're going to create a media, and then we're going to put that in the media player, and then we're going to use this set audio spectrum listener. We're going to see what happens with this method here. So after these prints, I'm going to create a instance here. So here I have the media instance. Inside the constructor, I'm going to pass a song. So I have a list of songs already. So based off the current class, I'm going to get a resource. The resource is going to be song. For now, I'm going to pass a song to this function, and then I'm going to say to external form, just like in our previous program. However, I need to put the media in the media player. So I'm going to create an instance of media player, pass in media as a parameter. Now, in this case, if I'm just playing audio files, I don't necessarily have to put that on the display. So you see in this example, I do not have a media view because I'm not going to be viewing the media like as in a video. So I can just play the audio in the back end, depending on what you're trying to do. With this example, I'm going to play the audio in the back end. The user will still be able to hear it, but they're not going to be able to see anything. Then I'm going to use this set audio spectrum listener. Now, if we do a show Java doc, what that is going to do is grab the contents of the audio file. So it's going to listen to the audio file. You'll see I have 4 parameters here. I have the timestamp, duration, magnitudes, and phases. So let's look at the Java doc and see what this is. So set audio spectrum listener is listening to the audio spectrum. So if I click on this right here as a parameter, you'll see audio spectrum interface. It observes and periodically updates the audio spectrum. You'll see here I have timestamp, duration, magnitudes, and phases. And you'll see it specifies what each one is. Timestamp of the event in seconds, duration for which the spectrum was computed in seconds. Magnitudes, these two are the most important, magnitudes and phases, is an array containing non-positive spectrum magnitude in decibels for each band. The size of the array equals the number of bands and should be considered to be read-only. Okay, so it should be read-only. Now this is a non-positive decibel value, and we'll actually see the range of those values. Okay, we'll see that in a second. Phases is an array containing the range from -pi to +pi for each band. The size of the array also equals the number of bands. So essentially, here's the decibels for the audio file for each band, and here is the phases in a range from -pi, +pi for each band. Now, what the heck does that mean? Well, let's take a look at the code, and we'll get a better example of what data we have. So on the media player, I'm going to set the number of bands. Okay, I'm going to set the number of bands to 4 for now, because you'll see I had 4 ellipses, and here's my interval. So I'm also going to set the interval. This is how many times I want it to update. So I'm going to set it to 0.01. Okay, so if I look at the Java doc, for this challenge, you're going to be looking at the Java doc frequently because you need to figure out what these methods are doing. So if I open up the Java doc for the interval, okay, you'll see the interval is in seconds. So I'm specifying at 0.01 seconds, I'm going to update the listener. You'll see the default is 0.1 seconds. So this is going to be updating frequently, and this is the spectrum listener. So at every 0.01 seconds, this listener is going to be called. You'll see if the length is greater than or equal to 4, I'm going to go ahead and print out the timestamp, the duration, the magnitudes, all 4 of them, because remember, magnitudes is equal to the number of bands, and so is phases. So I have 1, 2, 3, 4 phases and 4 magnitudes. Now let's check out these values. So if I run this, actually we need to call this setup UI and pass in a song. So in the initialize, I'm going to call it setup UI. Let's pass in a song. So you'll see I have songs up above. So I'm going to pass in songs 0 for now. Okay, let's see this run. Okay, give it some time. It's going to start executing. So right now we're not going to see anything in the display, but we will see items in the console here. So the output. So if I play, you'll hear the music is playing. And here's the data that I have with that music. So you'll see the timestamp is increasing in value. That's in seconds. And here are my phases and magnitudes. So if I look at magnitudes, you'll see these are negative numbers just like it's specified. And the range is actually going to be from 0 to -60. And these are different bands. So you can think about it, if you ever look at an equalizer for music, you can see the equalizer, you can see the different bands. So the low bands are usually the bass, the high bands are usually the treble. So I'm going to use those bands and pull information from the audio file, and then I want to use that information to try to update the display. So essentially we're going to be making almost like an equalizer here. So if I play the same song, let's say in iTunes, you can see this equalizer here. So here are different bands that I can use. So here, usually down here is the bass. You'll see the decibels as well. So here it's from -12 to +12. Right here they're not moving, but if I adjust these, you can hear the audio will sound different depending on how I'm adjusting these different bands. Now in iTunes, Here's one of their visualizers. So I play a song. You'll see the visualizer is going to change based off of the audio that's playing. Now, this visualizer will be hard to make, but essentially this is what we're going to be making for the challenge. Okay, you'll see these circles, dots, stars. You can see they're going based off the audio. Here comes the audio. It's about to start. So you should see more action. Okay, so essentially this is what we're going to create for the challenge. You'll see the circles are moving. I have action based off colors, how big and bright they are based off of what the actual audio file is playing. Okay, here's their classic visualizer. So if we play that same song, Closer to the Sun. Okay, now this would be hard to make because it's 3D. But you can use some of these visualizers as inspiration. Okay, you can see the audio wave, the frequencies here. That's what we're going to be making. You can see the different bands, the different decibels. Based off each decibel, it activates that specific frequency, and that's going to update the user interface. Okay, and that's exactly what this spectrum listener is doing. We get magnitudes, we get phases. We're going to use that information and update the display. We're going to take a look at an example in the next video, so stick with Professor Wergeles.